Alright guys, sorry I tried to actually add some music to this for you too, so it might make it a little more interesting, especially there at the beginning, but it was a failed attempt. So I'm going to keep working on that and try to get that figured out for you. Okay, so tonight we're going to be I'm going to cover one more example doing division, just so that I can show you something that didn't come up today that might be helpful to know how to do. And then we're going to move on and we're going to be converting between decimals, fractions, and percentages, excuse me. So I'm going to go ahead and use green. Let's take this problem. We got 3/8 divided by 9/2. Now if you guys remember from today, we're going to convert this to a multiplication problem. So it's going to become 3/8 times, and we have to flip this fraction. We're going to use what we call the reciprocal, which you guys should have looked up the definition for tonight, and that is going to become 2/9. Now, when I look at this, we can just multiply straight across, which would give us 3 times 2 would be 6, 8 times 9 would be 72. Then we'd have a really big numbered fraction that we'd have to simplify. So I'm going to make it a little bit easier for you. Whenever you're dealing with multiplying fractions, you can do what is called cross-canceling. And that just simply means that I can cancel diagonally. 3 and 9, 8 and 2. So you're going to look at them. Is there something that I can cancel out? So let's start with the 3 and the 9. Well, yeah, 3 is divisible by 3. 3 divided by 3 is 1. And I can also cancel out a 3 down here, and 9 divided by 3 is 3. Let's check the 8 and the 2. 2 divided by 2 is 1. And I can also factor out a 2 here. 2 divided by 8 is 4. This leaves me with a new expression to evaluate that would be, not 3, but 1/4 times 1/3. And now you can multiply straight across. 1 times 1 is 1. 4 times 3 is 12. And this is a lot easier. I get a simplified fraction. This is a lot easier than getting 6/72 and trying to simplify that fraction. So that's going to be the extent of the review we're going to do for tonight. It gives you a little bit of another view from it, makes some of these a little bit easier for you. Now we're going to go on to example 2, and this is where we're going to start converting from fractions to decimals, percentages, and back and forth. A lot of the ways of doing these are very similar, so once you can do one or two of them, converting from a fraction to a decimal to a fraction, throwing percentages in there is not very difficult. Okay, so when I take 5/8 to convert it to a decimal, we're going to go back to grade school when you guys learned how to do long division. And in doing so, we kind of talked about a little bit of this today. The 8 goes outside the division symbol, and the 5 goes underneath. Alright, so now you're going to ask yourself, how many times does 8 go into 5? Well, that's going to be 0 times. 8 doesn't go into 5 at all. So I'm going to put a decimal right here on the other side of 0, and I'm going to put one on the other side of 5. After I do this, I'm going to add a 0. Now you're going to ask yourself, how many times does 8 go into 50? 8 goes into 50 6 times, and 8 times 6 is 48. We're just going to ignore the fact that there's a decimal there. 50 minus 48 is 2. So now I'm going to look and I'm going to say, okay, well, how many times does 8 go into 2? Well, 8 doesn't go into 2, so I'm going to add a 0 here, and I'm going to bring that 0 down. Well, now I've got 8 into 20. How many times does 8 go into 20? Well, 8 goes into 20 2 times, and 8 times 2 is 16, so now I'm going to subtract again. 20 minus 16 is 4. And again, we're going to just keep repeating this process until we either get nothing left over, or until we notice a pattern in our decimal up here. So 8 goes into 4, not at all. So we're going to put another 0, bring that down. Now I've got 40. 8 goes into 45 times, and I get a remainder of 0, telling me that 5/8 converted into a decimal is 0.625. Okay? And the long division, you may not have done long division including decimals before, but you've done long division like 64 divided by 8. So this should be somewhat familiar to you already. Now we're going to take, for example 3, we're going to take a decimal and we're going to convert it to a fraction. So whenever we're dealing with decimals, the way to get rid of decimals is by multiplying by powers of 10. You guys should already know what scientific notation is, okay? So if I take 0.8 and I multiply this by 10, it means that I'm going to move my decimal one place to the right, and it's going to stop. So this would equal 8. If I have 0.8 and I multiply that by 100, it means I'm going to move my decimal 2 places. So I've got an empty spot here, so I'm going to add a 0. So I have 8, I need a 0, and then my decimal would go right there. So 0.8 times 100 is 80. We're going to take that same idea and we're going to use that to convert fractions. So you need to ask yourself, okay, whenever I see a number here on the right of the decimal, this is going to be my numerator, this number here. So my numerator is going to be 8. And I'm going to put that over. My my denominator is going to be whatever power of 10 that I had to multiply by to get rid of the decimal. Well, if we look at this problem, I need to move it 1 time to get the decimal on the other side, which means that my denominator will be 10. So now I have a fraction, 8 over 10. That is equivalent to 0.8. But our rule is fractions must be simplified. So I'm going to divide this by 2 and this by 2, and I'm going to get 4 over 5. And this would be my simplified fraction that would be equivalent to 0.8. First two examples, fraction to decimal, decimal to fraction. Now we're going to get into percentages. Percentages are fairly simple. With a percentage, it's along the same idea as what we just dealt with before. We're going to use one of the same concepts. But this time it's a set number. Okay, so whenever you're dealing with a percentage, or a decimal, and you're converting it to a percentage, you're always going to multiply by 100. It's the same idea as what we dealt with the other day with fractions, and I asked you guys what the whole was represented by when you're dealing with a fraction, and you said it was 1. Well, with a percentage, the whole percentage is represented by 100. So in order to get this into a percentage, I'm going to take the number and I'm going to multiply by 100 always. Multiplying by 100 means I need to move this decimal 2 places, which tells me that 0.45 as a percentage is 45%. And if you're going to work backwards, it's going to be the same. Okay, so if I want to, and we'll get to this in the next one, but if I wanted to take a percentage and convert it to a decimal or a fraction, I'm always going to put it over 100. And let's also take an example like 27. Let's take an example like this, 0.274. Well, same idea. Doesn't matter that there's 3 numbers here. I'm still going to multiply by 100. 0.274 times 100. So I'm going to move the decimal 2 places, 1, 2, and my percentage would be 27.4%. Okay, so percentages are fairly easy. They're usually not something that gives students too much of a problem. Let's go to the last example, and in this one we're going to take a few of the concepts we've used and we're going to kind of put them together. So right now we're starting with a percentage here, 22%. Well, when we dealt with converting a decimal to a percentage, we multiplied by 100. So when I want to convert it to a fraction, I'm going to divide by 100. So 22% would be the same thing as 22 divided by 100. Well, now I have a fraction. The last thing to check is it in simplest form? So I'm going to divide the top by 2 because it isn't in simplest form, and the bottom by 2, and I'm going to get 11 over 50. and 11 over 50 is in simplest form, so 22% written as a fraction is 11 over 50. I remember tonight, guys, this was the last example we're going to do for our notes tonight. So remember tonight, you guys owe me the definition for reciprocal tomorrow. If you didn't finish up your definitions today, then you need to get those other definitions to me tomorrow. And then you also owe me the skills worksheet that I handed out today, tomorrow as well as the notes. I hope you guys have a good night, and hopefully I can figure out a way to add some music to this so we can hopefully enjoy our videos a little more. All right, bye.